Check. Okay, welcome everyone. Before I get started, let's warm up a little bit, or at least give me a chance to warm up. How many Pokemon fans do we have here? Whoa. Okay, how many of you have watched the Pokemon movie? I Choose You. Oh, come on. Okay, good. So you get an inkling as to why by the way, that might be the title of the next movie. I'm looking at the Pokemon guys. Anyway, welcome everyone. So this is security track session. It's a 400 level session. So we're going to be looking at Pokemon's story about how they put together a solution or solutions to battle some of the bad bot problems they had. So we have with us Edward Smith and David Williams from Pokemon. Thank you guys for being here and sharing your story with us. So my name is Sundar Jayashekhar. I'm a product manager at AWS. So let's get started. So we have a pretty packed agenda today. So we're going to be going really fast. So slides will be available. The video will be available. You know that. So sit back, relax, and just take in as much as you can. So we're going to give a brief introduction into what the bot problems today are, some of the main bot problems. Much of it is going to be the Pokemon story. They'll walk you through some of their initial challenges, the first set of solutions, then how they evolve their solutions to make things better. Better scalability, better automation, auditability, so on and so forth. There's going to be a demo, an exciting demo towards the end. You actually get to test one of the solutions that they have, and a conclusion. Are bots a problem? This should really be a statement. I don't know why it's a question. So how many of you here, again, a quick show of hands, deal with bot problems on a regular basis? Okay. About 40%, 50%. That's good. For the others who haven't, you will very soon. So anytime you have a public web application, or do you have any kind of microservices, anything with a public endpoint, your bots are going to be a problem. So bots are there for certain purposes. The bad actors who use bots want to be able to scale the bad activity. So they make use of machines. That's why when you have bad bot activity. So there are a number of reasons for bots to exist out there. Denial of service is a very classic one, where there is excessive number of requests to your services. They try to overwhelm your backend resources, so there's an availability issue with your service. There might be partial availability. Basically, it ends up in being a bad experience to customers. So that's pretty well understood. Content scraping is nothing but stealing of content. So it comes in various different forms. E-commerce sites, it's very popular with e-commerce sites where there's something called price scraping. Bots are constantly scraping your site, cataloging the products, prices, so on and so forth. Not everybody likes that. So if you're one of them, then you need to identify those and shut them down. Account takeover, it's nothing but credential stuffing. If you get access to compromised credentials, you can use credential stuffing, which is basically brute forcing a login into any kind of an account. So you can use bots to do that. Unfair advantage is something that's very popular in the gaming industry. Basically, gamers use bots to play on their team to just defeat the other gamers online. So it's a popular one. Pokemon will go through their set of stories and troubles with bots. But this is something that we've heard from other gaming industries, other gaming companies as well. So bots are not there just to be a pain point or malicious. They're also there. They're getting more and more sophisticated. There are businesses out there that actually make money through bot activities. Ad tech industry, which is the online advertising technology industry, has a serious problem with this. Anytime somebody clicks on an ad online, somebody has to spend money and somebody makes money. So that equilibrium kind of gets messed up sometimes when the bot activity takes over. So these are some of the things that we thought we should mention as a warm-up to the session. There are many, many more use cases or malicious use cases for bot activities. So what to expect in this session? Again, this is a 400 level session, like I mentioned earlier. We'll spend very little time giving you intros into services. We just expect you to know those things so that we can just dive straight into the code and some of the other deep dive stuff. So today's session is going to be focused on the Pokemon issues, the problems that they solve with the bots. They'll walk you through their solutions. The crux of today's session is, here's what we had on day one. The solutions look like this. Here were the goals for the first solution, and how the solution evolved, both to meet new challenges posed by the bots, as well as doing things better. More automation, auditability, which didn't exist in the first solution, came in the later solutions. So that's the exciting thing about the session today, is you actually get to see an evolution of a solution from a customer. Towards the end, we'll also talk about some of the scaling and performance improvements angles of the solutions that went into production. And more importantly, keep an eye on how fast they were able to deploy new solutions as new challenges came up. So that's also something to watch out for. Again, I told you no quick intros, but we'll still show you some of the main services we're using today that Pokemon has used in these solutions. We have 3 edge services. We have Amazon CloudFront, AWS Web Application Firewall, and AWS Shield. The firewall is CloudFront is the CDN service. WAF is the Web Application Firewall, and Shield is the DDoS premium product offered to you through the edge services suite of products. Of course, Lambda, SQS, DynamoDB need no introductions. And you'll also see the solutions heavily use Kinesis suite of products. Kinesis Firehose for data ingestion, telemetry ingestion, as well as Kinesis Analytics for all things analysis. With that, I'm going to hand it over to David.
All right. So I want to start off by talking a little bit about the Pokemon Trainer Club system. If you're not aware, the Pokemon Trainer Club system is our worldwide authentication service, and it grants access to a number of different Pokemon sites and events, as well as games. Things like the Pokemon Global Link for the Nintendo 3DS platform, for example. The trading card game online, which if you've ever played our trading card game, our physical card game is a digital representation of that. But probably the one that everyone is most familiar with recently is Pokemon Go. And so the success of Pokemon Go brought a lot of new challenges for the Pokemon Trainer Club system. On the one hand, we saw a massive increase in new users, which is something everybody wants. But it did require us to quickly scale out our infrastructure to be able to handle that new capacity. At the same time, we also started to see an uptick in accounts that were used for what we would term as bots, accounts used as scanners to look for Pokemon in certain areas and build maps of those areas so you can go and find the best Pokemon. Accounts that are automatically leveled up and sold, so you don't have to start at level 1, you can start at level 30 and impress your friends. And then finally, we started also to see an uptick in disturbing denial of service type attacks, or attacks that would make disrupt or degrade our service for end users. And so where we left off last time, if anyone was at reInvent in 2017, you might have attended our session along with the Amazon DRT team, where we talked about how we moved our system from our original cloud-routed WAF into AWS WAF and Shield. And doing so greatly improved the performance and stability of the Pokemon Trainer Club system. And we were able to get started pretty quickly and get cut over pretty quickly, porting over a lot of our original WAF settings, string match and IP match conditions, as well as be able to take advantage of some of the out-of-the-box services that WAF provides, like cross-site scripting protection, SQL injection protection, things like that. We were also able to get set up with the global rate limit, which, if you're not familiar with that, is a setting that says any one requester, any one IP address, for example, cannot make more than X number of requests in a 5-minute period, or they start to become blocked up until they get underneath that level. with the lower limit of that being about 2,000 requests over a 5-minute period. But more importantly, we had greatly improved the stability of that platform and reduced the amount of downtime for our users. So we were done, right? All the bots are gone. Unfortunately, no, but we did accomplish our primary goal, which was to improve user experience. But we still had a number of illegitimate accounts, and these accounts would, and we actually established an equilibrium even with this additional traffic, as long as our services and all of our partner services remained functional. The only trouble with that is that services fail. And so what happens when services fail? Well, so this is what would happen when one of our partner services would fail. And the orange line in this graph represents all of the traffic received at the edge at CloudFront, where the green line in this graph represents everything that's being handled by our backend systems. And you can actually see that the WAF rate limit and the IP match and string match rules that we had in place were doing a pretty good job of dropping traffic. But we were still getting what looks like about 10x increase to traffic on our backend servers. And even with good auto-scaling, it's very hard to keep up with that demand. So we needed to do something more. We needed to take that next step with how we use WAF to improve our user experience. So we turned to Amazon Big Data blog and their CloudFront serverless analytics blog. And if you're not familiar with this, I recommend, the link is up here, I recommend taking a look at it. It's really easy to get started. This diagram is kind of a simplified version of that. But it basically starts with your CloudFront logs, which you're probably already sending to to an S3 bucket. And from there, we do a little bit of partitioning, a little bit of processing on those logs through Kinesis Data Firehose, and then we can query them with Amazon Athena. At the same time, we also set up a Kinesis analytics application, as you can see in this diagram. But after a little bit of looking at it, we didn't find a whole lot of use for it at first. It will come into play a little bit later, become more important. So we were able to use Amazon Athena to start to look at, start to break down that traffic. Who are our top requesters overall? We can filter that by URI. We can filter that by status. So if we go back to the previous graph, and we don't want to look at everything that was dropped. We don't want to look at everything that was returning a 403. We can filter that out and just look at what traffic was getting through. We can use adjustable time windows to only look for traffic in the time windows that we care about. And we can start to, as an incident response or as a postmortem, take a look at these events and see what's going on. So what was going on? Well, unfortunately, our bots weren't friendly enough to pass a "I'm a malicious bot" header to us. So we had to look at other bits of information. What did the request and the response flows look like? What were the headers that we were passing? And who were the requesters? And as it turns out, what we were getting was what looked like, for the most part, normal mobile and web client traffic with normal request and response flows. So we had to look at other bits of information, and so we started turning to who were the top talkers overall. And we found out something interesting about that. We found that over a very short period of time, 1 minute, 2 minute windows, we would see requesters log in thousands of times. And I don't know about you, but I tend to prefer the gameplay experience over the authentication experience. So that looks suspicious to us. And so we were able to take some of that information, go back real quick, we were able to take some of that information and improve our IP match and string match conditions and drive down some of that traffic that was causing negative user impact. But you can probably already tell that that solution is going to have a lot of inherent problems. The first of which is that it's high touch. It takes a human user to look at the Athena console and see and run the saved queries or come up with new saved queries, do some analysis on the data, create new rules or update existing rules, check out the effectiveness of those rules and modify them as needed. At the same time, our bots were doing a pretty good job of adjusting to that strategy. When at first we were able to get some relief for a couple of days, and then it turned into a day, and then it was maybe a couple of hours, and then finally about 5 minutes. So it became a lot less effective over time. At the same time, all of these rules that we were putting into the WAF had to be logged somewhere, and there's no real good way when you're creating IP match rules or string match rules to link them back to why you created them, what the condition was, when those rules should be removed, and things like that. So we needed to improve that audit trail. And so we started planning a new solution.
So in order to go through and come up with an effective solution, we first needed to find what our goals are. Our first goal was to make bad behavior more expensive. We knew we weren't going to be able to get rid of bots. It's not realistic. There's always someone who's going to be able to circumvent whatever you do or react faster than you can. But what we could do is we can make them pay for more infrastructure than we have to. We all know that infrastructure can be expensive, and if we're paying for it, they also have to pay for it. So our first goal was to make it so that badly behaved bots have to pay more money. The next one was to reduce the risk of false positives. Blocking a hosting provider is not the end of the world. We know who our partners are, we know where those requests should be coming from, but people are using residential IPs. It's not nice to go through and use your IP and then have your neighbor get it the next day and it's blocked because you were doing something bad. We wanted to make sure that if someone did get blocked when that IP went to their neighbor, it would not be blocked for a long period of time. That the penalty for them being caught and for us blocking it would not hurt a lot of other people. Another big one was set and forget. We're busy. We have a lot of stuff going on. I'm sure you guys are all really busy. We didn't want something that we had to constantly adjust, that we had to constantly maintain. We really wanted something that we could deploy, set out there, define the rules, pass off to our InfoSec team, and then just sort of forget about it. We'd obviously have to update it, which you'll see a couple iterations of it, but we didn't want it to be something that required everyday maintenance from us. Another one that David mentioned earlier was an audit trail. What he didn't say was what our previous audit trail solution was. We had a Confluence page that we updated every time we blocked an IP. Yeah, not ideal. I've made typos typing an IP into a browser. I am sure that we have made hundreds of typos typing IPs and subnets into a Confluence page, and we would never notice them unless we tried to go through and audit it. And I don't really want to audit scraping a Confluence page to compare against what's in an AWS IP set. Not fun. So we wanted something that had a built-in audit trail, a little bit less manual Confluence page editing. Another goal for us was all serverless. This is because we're lazy. We didn't want to have to maintain infrastructure. We didn't want to have to patch it. We really just wanted to go through and set and forget. And the best way for us to accomplish that was, in our case, serverless. And a little bit sneak peek for the next slide, but the other reason for serverless for us was to go through and make sure that we could scale really easily with the shortest amount of time. The spike you guys saw earlier happened over a very short period of time. We wanted to make sure that we could respond to those and that we didn't have to be woken up in the middle of the night. I like a good 8 hours of sleep. I'm sure you guys all do, and I really don't want to be paged at 2 o'clock in the morning, multiple times a month. As I mentioned earlier, scale was a big one for us. The spikes are huge. You just wanted to be able to respond to that as quickly as we can. It can go to 10 times, 100 times traffic with no notice. It can drop off just as easily. The last one is we needed something that was fast to implement. We had 2 weeks to design it, to implement it, to test it, and to roll it out. We were able to accomplish the first iteration in about that time frame. If we didn't get it done then, we had pretty much decided that it probably wasn't going to happen for a year or more, just because there were other priorities coming up. So let's dive into what these goals resulted in. There we go. OK. This is the architecture. I'll dive into some components of it, and we'll sort of talk through it. As was mentioned before, we have cloud. I will be honest, actually. We skipped a couple pieces to make it fit on a slide. CloudFront is actually going through and getting processed by Firehose, which is then ending up in an S3 bucket before going through to Kinesis Analytics. The reason for this is we needed to clean up. Now, what are we using Kinesis Analytics here for? It's to go through and turn this raw data into time series data. Yes, looking at one specific request could be useful, but we didn't have any unique identifying features that said, this is a bot. So we needed some way to turn it into something that we could use, which for us, at that point in time, was time series data. And that was our starting point. The next step from there is we pass that to 2 Kinesis streams, which then goes to 2 lambdas. We have the whitelist lambda down on the left, and then we have the ingestion lambda. The whitelist lambda is a way for us to go through, well, step back. CloudFront doesn't tell you if something's been whitelisted or if it's been blocked, and we didn't want to have to pay to store all of the whitelisted IPs inside of a record that we'd get every request for effectively. That was not something that was efficient. We also have limited space in our IP sets. So ignoring stuff that's already been whitelisted, where we know we're going to be getting a lot of traffic from that we don't care about, is something we wanted to remove from there. So that's why we have the whitelist stream, whitelist lambda, and the whitelist table. The ingestion lambda does a lot more fun stuff. That's actually where the processing happens. It's going through and it's taking this time series data, it's storing it into the IP details table, and it's also going through and making a decision. Should this IP be blocked? If the IP should be blocked, we go to the WAF update queue. Every update to the WAF goes through there. Additional removal, and we'll talk through that in 1 second. But once it goes there, it then goes to the update lambda. We'll also talk about why we're using SQS here instead of another Kinesis stream. The update lambda updates the IP list. It also writes to a blacklist table. We did this is we wanted to reduce the amount of effort our InfoSec team had to go through and do to remove a false positive and to be able to remove something. So whether it's removed automatically using a TTL from DynamoDB or it's removed manually, all you have to do is delete it from the DynamoDB table. All you have to do. And then we also have a table for logs. We're also sending it off to our data lake that's not visible here, but again, had to fit on a slide. So let's talk about some of the pieces for it. Ingestion. This is an example of the first iteration of the Kinesis Analytics query that we're using. Fairly simple. We're grouping by request IP. We're also looking at the couple other things, including the host, and we're adding some details for it. And then we're also just grouping over a 10-second period. That means that you could go through and you could look at any 10-second period for blacklisting. The other next sort of part to that is the processing. I'm going to admit something here. This is actually a sneak peek. This is the processing code from our newest iteration. It's a lot more interesting than the processing code from the original one, so it got stuck in here. But effectively what we do here is this is where we're actually checking. Does this match a rule? What do we do with it? In this case, we have a rate limit rule, or we have an unsupported rule. It's very basic at this point. And if it goes through and if it is blacklisted, we can have multiple rate limit rules. So if it breaks the rate limit by more or hits a more severe rule, it could have a different TTL and we could blacklist them for longer. We could theoretically blacklist something for 100 years here, and it'd be effectively blacklisted forever. The other key part of it is storage. I mentioned serverless before. We really had one option for serverless data stores in AWS, which was DynamoDB. It actually worked out really well for us, though. It had a lot of functionality that we needed. It worked well with JSON. It's also a lot easier for us to process JSON in the middle of it. And Kinesis streams JSON blobs works really nicely. Had a TTL to remove blacklisted IPs when they were meant to expire. There's one gotcha here that I'm going to call out now. It'll become important later during our demo. But you're not guaranteed to have something removed immediately with a TTL. It could take up to 48 hours. For us, that was acceptable. It may vary for other people. But our whole goal was that it wasn't blacklisted forever, and we found that it actually removes it pretty close to the TTL in most cases. The other nice thing about TTL is with DynamoDB and with time series data, you're going to end up storing a lot of data. We don't want to store all the data. We don't want to store a month's worth of time series data for all requests that hit our database. That's a lot of money to throw away for data we're not going to really use. So going through and using the TTL to clean up the IP details table was huge for us because it allowed us to pay less money for the throughput, less money for the storage, and all the queries were also faster.
So we'll kind of cover this last section all at one or in a couple of slides here, but this is kind of where the magic happens and where the violators then get placed into the WAF IP set. And so the first thing we want to do is we want to take as many messages off the queue as we can. And we talked, you might be wondering why we're using a queue here, and why don't we just stream this directly into into Lambda and then into the IP set one at a time. And there's a couple of reasons. For us, it ended up being a little bit more efficient in terms of time to process all those rules to use the queue. And then there's another issue that you might run into doing that with the change token, which we'll talk about in the next slide here. But the first thing we want to do after we take all those messages off the queue is start to dedupe them down. We expect there to be a number of duplicate violations in the queue when we pull it off, and we want to only pull the one that has the longest TTL, the one that is going to have the longest blacklist period. The rest of them is just going to take up space in our API call, and we can only make 1,000. We can only put 1,000 IPs into one API call, so we don't want that. We also dedupe adds and deletes separately. The reason for that is because we can't make we don't expect there to be duplicate delete requests, but we don't want to make any assumptions about what messages we're pulling off the queue. And if you try to include multiple delete requests for the same IP address in your IP update, that will cause it to fail, and you'll have to start the process over again. And after all this processing, we don't want to do that. All right, we'll go on the next slide. So I mentioned the change token. Every WAF IP update has to have a change token, and that change token is good for the next change. Now, if you happen to be making updates through the API, or you happen to at the same time be making updates through another process or through the UI, you may run into a change token conflict where your update just won't go through because that change token was already used. And so for this, we actually put it into a loop. But this is the primary reason why we wouldn't stream requests directly off of Kinesis and into a Lambda to process one at a time. So that's basically the update Lambda in a nutshell. The TTL Lambda, all that does is it takes the request off of the blacklist stream once those violations have timed out, creates a delete message, drops that onto the queue, and we start the whole process over again. Very simple.
So I mentioned scale before, so we're going to dig into scaling a little bit. The first one we're going to touch on is Kinesis streams. This is a big one for us. It's because all the requests are throwing through multiple Kinesis streams before they end up in SQS. The big one for us that allowed us to scale very nicely is the fact that a Kinesis stream is made up of multiple shards, and each shard will invoke a Lambda once, about every 10 seconds maximum. This was huge for us, because this meant that in order to scale, you add more shards. And then all of a sudden, you have more Lambda invocations. It was as simple as that. There were a couple gotchas with that, though. Shards, just like with partition keys in DynamoDB, have something like a partition key in DynamoDB, which defines how it gets associated with a specific shard. If you choose a bad partition key, like host that it's hitting, you're going to get all of your traffic going to one shard, which means you're going to have one Lambda invocation effectively trying to process all your traffic. Doesn't matter how many shards you add then, you're going to have a bad time. The other key part of it is you can at most double the number of shards you have twice in a 24-hour period. So if you start off with 2 shards because you're like, well, I don't know how many I'm going to go with. I'll start off with 2 and we'll scale up slowly. It's going to take you a while to get to anything useful. I will be perfectly honest. I started at 2. It took me about a week to get up to about 256. Not a fun process. I'd highly recommend you start with something a little bit larger because doubling 10 is a lot more efficient than doubling 2. The other key thing with it and with Lambda is that Kinesis streams will automatically, and Lambda interactions will automatically retry data if it fails. This can be great. You have an intermittent failure, it retries, it succeeds, you're good to go. But what if your data is formatted incorrectly? All of a sudden you have bad data backing up your stream that isn't going anywhere until it expires, which the minimum duration for that's 24 hours in Kinesis streams. So you have to make sure that you have proper error handling for issues that will not go away, and a good approach to that may be to put them into another stream and then to process that somewhere else or get notifications for it, or maybe just drop it on the ground depending upon what the specific use case is. The other one that we found was very important for us for scaling was the Lambda. Not only getting a lot of Lambda invocations to execute, but also to make our Lambdas more efficient. Our Lambdas had to execute within 10 seconds, and we had to be processing more data than was being put on the streams. If it wasn't, the streams would keep backing up, we'd have to scale out, it would take a while. It was not a good situation to be in overall. So one of the key things that succeeded for us was variable reuse. All the examples will be in Python, should be able to do something similar in pretty much every other language out there. Literally every other language out there now, I think, with the new Lambda functionality. But for us, a great example of that was doing a rule refresh, is we could cache the rules in memory, and that we could then make sure that we weren't processing them constantly, which the rules could include regex, they could include a database call to DynamoDB, and all of that can be somewhat expensive, especially if you're trying to do it every call. So caching that, in our case, 4 to 6 minutes to prevent rushes on the DynamoDB database was very efficient, and it reduced the amount of execution time by a fair amount. The other big one for variable reuse is going through and using things like caching service handlers, or the services in Bodo 3 in our case. It actually cut about 10% of the execution time off, which was very surprising for us. We sort of did it just because it was convenient to start with, and we looked at how fast it was executing afterwards. Like, that is interesting. But it was interesting enough and had enough of an impact that we're doing it pretty much everywhere in our Lambdas now that have a high throughput requirement. There is one gotcha with variable reuse. Is if you're trying to use a variable across multiple modules and you just said, it's going to be a global variable because I don't really care about programming practices, you might accidentally have it being reused in another invocation. Because behind the scenes what's happening is you might go through and you might have the same Lambda container being used for multiple data calls, so you could end up with effectively contaminated invocations after that, which is less than ideal. We actually did that a couple times, and it sort of blocked the processing of some of the records for a little bit until we figured out what it was. Another big one for us, as I mentioned rule logic before, even going through and only fetching the rules every 4 to 6 minutes, and only updating them if there's been a change, can still be expensive. Actually, this is not updates, though. This is the logic itself. So one of the key things here is actually going through and making sure that you do the processing for the rule logic in something that makes sense. It's expensive to do a regex comparison, even assuming the regex is already compiled, which it is here. But you still have to go through, and you still have to go through and do an expensive operation. So what we did is we put that as the very last. And going through and paying attention to those little minutiae, effectively, of how you're writing your code can have a big impact. Is if we'd put that first, that would have been effectively being run for every single request. We would have been going through and we'd been matching at least one regex expression against every request that we get over a 10-second period. We're not going to go into DynamoDB a lot here for scaling it. That's its own talk. I'm sure there's entire classes about that. Couple big gotchas. Throughput dilution. Pay attention to how many partitions you have. Pay attention to how much throughput you have allocated. Make sure you clean up old data. All sort of goes together. Spreading load across partitions. I mentioned hot partitions earlier, or hot shards earlier, but the same thing applies here. You want to make sure that you have a sensible primary key that shards nice or hashes nicely so it's split across all of your partitions. And then the other thing is don't keep data longer than you need to. That was a big one for us. We only keep the data for pretty much as long as we need to use it for processing, and then we dump it. And it saves us a lot of money and just a lot of storage space and a lot of time overall. So short recap. This is the first iteration. Well, second iteration. The first one was a very manual process that David showed earlier on. So this is the first iteration. Let's go and look at the final solution that we currently have. You'll notice the bottom left-hand corner is a lot emptier. All of that whitelist logic is now gone, and what enabled us to do that was that we're now using WAF logs. That was a huge change. It came out in, I want to say around August of this year is when it was available, and it allowed us to go through and look at what action the WAF was taking before we decided on the action we were going to take. So if the WAF went through and said, well, this traffic was whitelisted, we could then go through and say, well, we don't care about it then. We know that even if we blacklist it, nothing's going to happen. The other one is we have this rules table down there now. There's a dirty little secret that will come up in a slide as to what we were doing before. The rules table was a lot more friendly. We'll just leave it at that. We also went through and we were able to simplify Kinesis analytics. The big gotcha before was that we were actually doing some regex matching in Kinesis analytics. That meant that if you wanted to update what the rule was and what the regex matching was going to be, you sort of had to update it in 2 places. And that was less than ideal. We also, that's it. I already mentioned WAF logs. The big one here is you'll see on the left, we have a Kinesis stream, we have a Lambda, and we have a DynamoDB table. On the right, the highlighted yellow line, it looks like it shows up on the TVs, is the only thing that replaced all that. We were able to replace 3 things with 1 line of SQL inside of Kinesis analytics. Pretty good trade-off for us. I think that one's pretty much a no-brainer as to why we'd want to do that. This next one probably will be as well. Yeah, before we were configuring the rules through CloudFormation that are being passed into our Lambdas as environment variables, less than ideal, but it was very fast to implement, which is what we were going for the first time. Not very dynamic, though. On the right is what we're doing now. We go through, we have a rule ID, they're versioned, they're only being updated in the Lambda if they have to for the cache. We can have URIs, we can add additional rule types by just entering them into DynamoDB and making sure that we have the logic in the Lambda. It's so much easier. It also means that we don't need to go through and make rule updates, as we can pass it off to our InfoSec team or to someone else in our org, and then just sort of forget about it until something breaks. We also can go through and adjust the TTLs a lot more dynamically here, and we can also look at the period over which we're checking to see if someone's exceeded the blacklist. In this case, it's 360 seconds. You'd have to make 75 requests, and you'd be blacklisted for 60,000 seconds. Not sure what that is off the top of my head. I'm not doing that math. The final one, you've sort of seen this one before, but we were able to simplify the Kinesis Data Analytics query. The yellow line here, we will go to the next slide. There's now a different yellow line, and you can even see it's a lot smaller on the screen. The reason for that is if I go back, that was going through, and that was a regex expression that was going through and saying which queries we cared about. If we go back one more, oops, too far. That was replaced by this URIs block inside of DynamoDB. It was a lot more efficient, a lot easier to update, and the risk of it, because if you make a mistake, you roll back to the previous version. It's a lot easier to adjust. Too far. Sorry guys, going the wrong way now. There we go. The other key thing here is this is what allowed us to do the whitelisting as well. Is we were able to say if the terminating rule ID is not the default action, and if the action that was taken was allow, then we want to go through and we want to say, yes, this was something that was whitelisted, this is what we're going on. What enabled most of these changes was WAF logs. This is an example, a partial example of what you get from WAF logs. I couldn't include the entire thing. It's in the docs. I'd much recommend reading that instead of looking at this slide later. But what you get here is you get a lot of information that you just don't get from CloudFront. Specifically, you go through and you get the headers. It's not really available from CloudFront inside of the CloudFront logs. You can get some of the arguments that you wouldn't have necessarily, and you get information about which WAF it was hitting, what action was taken on it, what rules it matched to, and there's some additional stuff in there that was also could be used dependent upon what your use case is and dependent upon what you're interested in. These are pretty much shows everything that we are looking at right now or will probably be looking at for the short term. So, is this the final solution? Is this all we can do with it? No. There's so much more that we can do. One of the big ones is whitelisting. I've actually had a ticket open for our InfoSec team to implement this one for a couple months now, but we'll get around to it eventually. The big one is that right now when you whitelist, you're whitelisted forever. That's not great, especially in a lower dev environment where you potentially have vendors that are integrating with it, or you go through and you have to whitelist some other office because you're at a conference. I mean, you have all sorts of reasons you might need to whitelist something. But once you add it to a whitelist, you don't know why it was added. You don't know when it was added. It sticks around forever. And you don't know who to contact in case you were wanting to say, hey, can we remove this now? We had a solution for that. That was, once again, a Confluence page. A much better solution would be a DynamoDB table. You can use TTLs. Yes, you have the 48-hour limit. For whitelist, I think that's even less important. You can also add any additional metadata to decorate it as you want. And you can take automated actions. You can also go through and you can get notifications if a whitelisting IP potentially starts misbehaving because you'd set up an email to notify instead of just having it fire an alert to your NOC. We're actually pretty sure that we could take portions of the previous solution and just cut them out and re-architect them a little bit, and you'll have a whitelisting solution. Because a whitelist is just an IP list that has an allow rule associated with it. That's all you're doing, which is all we have right now is a IP list that has a deny rule associated with it. We could also look at a lot more advanced behaviors. One of the big ones is we can get a lot of additional information about IPs. Who owns the IP? Where the traffic's coming from? Is it belong to a hosting provider? Is it a mobile IP address? Is it a residential IP address? Does it belong to one of our other offices that we forgot to whitelist? All of those are possibilities that you could automatically take into effect when making a decision. You just have to pull that data from somewhere and probably cache it. It's not actually that hard to do. The second one is, if someone keeps misbehaving, you probably want to start being meaner to them. They're not getting the hint. So what we can do is we can say, well, you've been misbehaving for the past day. Let's just go ahead and block you for a week now. We don't care anymore. We can block you for a month if you're going to keep misbehaving. And we can go through and we can take advantage of that, and it can actually reduce workload potentially on this main processing engine because we could offload that to a longer-term view. The other one is what if we block misbehaving subnets? There is a limit to the amount of IPs you can have in an IP list. There are ways to shard it across multiple IP lists. But why not just block an entire subnet? If 75% of the subnet's misbehaving, can we block it? I probably wouldn't make that decision without looking at what the subnet is, which is one reason why we haven't done that yet. But if you start looking at who does the subnet belong to, is it a hosting provider, what country it is it an area where we even expect traffic to come from, you could potentially automate that decision. And depending upon what the risk is for you, you might be able to make a different decision. It may be an easier option. The last one is to look at multiple series of data. It's really easy to get a blacklist or to get a rate limit for someone to do a little bit of experimentation and to figure out what your rate limit is. And if you have a set of 5,000 requests, now they're sending 4,999. Yes, they're sending more than they were before, but it's not quite what your goal was. And going through and being able to look at it over multiple time periods makes it harder for someone to reverse engineer your blacklist or your rate limit, and also goes through and makes it so that you're catching the people who are already going through and implementing that behavior. Again, you can't get rid of the problem, but what you can do is you can make it so they're not as badly behaved. One of the biggest issues for us wasn't the bots themselves, it was terrible retry logic, is a great example. So now we're actually going to go through a little bit of a demo.
Yeah, we're a little bit ahead, but I think that's OK. All right, so the first thing we're going to do, and it's kind of hard to see this entire thing flow through the system, so we're going to put some slides up that kind of show you how it works first, and then we'll have a little bit of demo where we can try it out, and then we'll bring Sundar back up for a conclusion here. So, all right, so the first thing, the whole thing starts with connecting the WAF logs into a Kinesis Firehose. We've set up this Kinesis Firehose to first, and then we point the WAF logs at it. From there, the Kinesis Firehose will deliver the raw logs into S3, where we can continue to query them with Athena, if that's what we want to do for longer term or more complex queries that we're not handling within the automated blacklist. And then, of course, we also send the data to Kinesis Data Analytics application, so we can convert it to time series data. From there, the Lambda looks at the requests off of the Kinesis stream shard and determines whether it's going to violate, also pulls down the rules list, does a comparison, and determines whether those requests are violating those rules. If it is violating the rules, it will drop a message into Amazon SQS, where it waits to be picked up by the WAF blacklist Lambda, at which point the Lambda will process those rules, dedupe them, as I mentioned earlier, create the entries into the WAF table, write those into the DynamoDB table, so that, and with the reason and everything you can see here, we can see why it was blacklisted and what the rule ID is, and you can't quite see it on the screen here. We'll see it in the demo, what version of rule that updated, as well as the TTL, so we can see when that request is likely to be removed from the blacklist, depending on how quickly that TTL is processed. Once that record is removed from the DynamoDB table, we put a delete message back onto the queue, super simple, and the WAF blacklist Lambda again picks it up and removes it from the IP set. At that point, traffic is allowed again. Okay, so quick demo. I'm going to put a URL up on the screen. What we're going to ask is if you want to connect to this URL through your phone or laptop, either way. What you will find there is the API Gateway example pet store app sitting behind a CloudFront distribution, which we've protected with WAF and our automated blacklist. We've also decided that if you try to connect to this app more than twice in 30 seconds, because we really don't want you looking at that data, you will return, we will then put you in the queue to be blacklisted, and you will get a 403 the next time. Yeah. So this entire process will take about 1 to 2 minutes. So I think we'll take
a couple questions,
and then we'll pull up the charts.
Yeah. Quick note, too, is we will be outside of this room afterwards if people have additional questions. But while everyone's hitting the URL and trying to DDoS our blacklist from the 29 or so IPs that we're all natted through.
93.
93 IPs that we're all natted through, give or take. Are there any questions? Yes, yes. Okay, so the question is, what is our take on the motivation of the people behind this? The first thing I want to say that David sort of mentioned earlier is in 99% of cases, they're not malicious. They're just lazy. It's true though. They will go through and they just have bad retry logic is what it comes down to most of the time. Instead of going through and having an exponential backoff or saying, well, this appears that the service is down, we're going to stop the service for a while, and they'll go through and they'll retry and they'll retry and they'll retry nonstop. So they effectively are creating a flood every time there's a little blip. It could be as simple as one of their servers going through and having an issue where it's not looking at our responses correctly, so it thinks that they're invalid. And then what it does is it just retries nonstop, and it can create enough traffic that it starts to impact other services. And then all of a sudden you have this cascading failure effectively because of one poorly written bot. The reason that they're actually botting against us is because usually it's a business. There's two main use cases that we see. One of them, if you've ever played Pokemon Go, you have to wander around on your phone and you find Pokemon. The key is you're supposed to wander around. Some people don't like wandering around randomly, so what they do is they will go through and they'll write a scanner that uses fake accounts to go through and to say, hey, are there any Pokemon in this area that I'm in? And the answer is they'll then publish this an entire map. And now it wasn't just one site doing this, it was a ton of sites doing this. And by doing that, they have a need for these accounts. The other one, as David mentioned as well, was selling the accounts. People would pay money to go through and get an account that's at level 30 or with specific Pokemon, and it was actually a real business model. And that was one of the big ones as well, is if there was a possibility for a financial gain, then they were going to do it. So that's the motivations that we were seeing, and that's really what they were the issues they were causing. And that's the most important thing is we did have some malicious people, but most of the time it was just someone being lazy. Any other questions real quick? Yes? Yeah.
So our data isn't very interesting outside of it belongs to people. And so oftentimes we get DDoS from people trying to get account credentials that they can use for social engineering on something that isn't.
Yeah. So for anyone who didn't hear what he said is that he works for a university and their information is not necessarily that interesting other than it belongs to people. And that can be enough to go through into, for some people to try to get the information and to go after it. And that's, I think, a good point, is there are all sorts of different reasons to go after this. And one of the important things to note, too, is for most of our traffic, it is mobile traffic and not web traffic. And that's an important distinction that can come up at times.
All right. So we're gonna do this a little differently than we did yesterday. So here is the DynamoDB table before we started today. This is the table the blacklist table that tracks all of the violators, and we're just gonna refresh that and see. Oh, there you go. So I'm gonna move this over real quick, if I can find it. There it goes. So yeah, again, you can see the rule ID and the version which was violated. And if we switch over to CloudWatch real quick, yeah. So thanks. None of you will be able to reach our pet store app.
If you guys want to check back later in, and if you don't hit it too many times, you will see that you will be unblacklisted. I
just want to double check. Did anybody get a 403 from CloudFront? Yeah, that's what I thought.
Yeah. It's working still.
It's working.
And that's one of the key things is that you will be unblacklisted because of the 48-hour range that I mentioned earlier. It may not happen immediately. I think we actually only set the TTL to about 5 minutes.
It's 5 minutes, but because the shards are cold, it probably takes a little longer.
So we would check back in probably sometime tomorrow. You'll realize you'll hit it. If you check in back in twice, you're going to get blocked again.
By the way, we did see people from the last session checking in multiple times, so we know. Let me switch back. All right, I think we're going to bring Sundar back up, and he's going to walk us through the conclusion.
I got it. Yeah. Okay, thanks, guys. How was that? Did you guys like it? Definitely a Pokemon fan. So the couple of things one was a question, one was a comment. I'm going to get to the slide a little later. One was I hadn't noticed in the first session the simplification of the architecture, the whitelisting architecture. That was pretty cool. I mean, this is one of the reasons why we actually put out a couple of months ago the WAF logs. People really wanted the additional data in terms of, when you give us the log, I mean, CloudFront logs is awesome, but it doesn't have the contextual data that the WAF has in terms of the rules that matched, the complete raw request, and things like that. So we're really happy that you could make use of that and simplify the architecture. And I forgot what the question was, but let me move on. Again, so key takeaways from this session is, bots are a problem. Take it seriously. We've shown you how one customer has implemented the solution and kind of evolved the solution using the building blocks that we provide. Again, we provide you many building blocks, many weapons to attack the problem with. This is one way. There are many other ways of doing it. I mean, we talked about some of the dumb bots that don't have a good retry logics. A lot of the bots out there have very good retry logics. We have a strategy called feeding the bot, where you have to send it to 200 OK for it to back off. So yeah, keep that in mind. We are doing a few things on our side, on the WAF side, CloudFront side, to be able to help with those scenarios as well. Again, evolve your solutions, because the bots don't sleep. The bots are constantly evolving. It's not just the 16-year-old sitting somewhere in Poland running a script kiddies. There are also very sophisticated folks out there, just as good as developers. Nothing against Poland, but that's just the name that came to me. I have a very good Polish hacker, a very good friend of mine. That's the reason I use that example. So again, hope you guys learned something from this session. Hope you go try stuff on your own, and if you have any questions, feel free to contact me or anybody from any of the service teams. Great, thank you. We'll be off stage. If you guys have any Q&As, we'll be happy to take any extra questions. Don't forget to put in the feedbacks, and that concludes the session. Thank you.